Hello and welcome to Course 3, Advanced Lessons in CodeJumper. This is Lesson 18 on binary numbers. After this lesson, students will be able to understand the concept of converting numbers between two different bases, between binary and decimal. The expected outcomes are that students will understand that computers use binary numbers to represent information. Most students will be able to convert between binary and decimal numbers or understanding of it. And some students will be able to explain why computers use binary numbers and how they represent letters. So we have a lot of vocabulary for this lesson. So let's just go through it. We have binary number system. So this is a number system that computers use to represent data with zeros and ones. And we'll see that more in detail in a moment. Then the decimal system, which is commonly used, where each number is represented by digits from 0 to 9, and the place value has a power of 10. So place value, the value of the number based on its position. And we have a bit, so binary, a bit is a digit with either a 0 or 1 as a possible value. And we have a byte, a sequence of 8 bits, with 256 possible values from 000000000 through 11111111. So there's 8 place values. Okay, so this first lesson is really understanding that place value for binary numbers and how to convert numbers from our decimal system into binary. So we're going to be using cards and having a physical activity, and the cards are blank on one side and the other side either has a circle or a tactile marker or something on it. And we'll go into more detail in a minute. But first, let's start with talking about decimal and binary and how do we look at that? That makes sense to us. Well, decimal we're used to using. We use the base 10, 1 through 9, and we have our lovely 0. But we have 10 fingers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So we can count our fingers. It makes sense to us. In binary, it's like a light switch because in computers, things are either on or off. So the values are a 1 if it's on, if it's off. So we have ones and zeros. So it's a light switch or our hands, or a more tactile way of looking at it. Okay. So in this introductory lesson, we have our different places, and most students know that in decimal we have our ones place, our tens, our hundreds, and our thousands, and so on. And in binary, we have our ones, we have our twos, we have our fours, we have our eights, and we have our 16s. Let's put this into a table so it makes a little bit more sense. So I have a table up on the screen in base 10, which is our decimal system, where we have, starting on the right to left, ones, tens, hundreds, thousands. And below that, I have the number of each one of these that we have. So in the ones, I have 0 ones, I have 7 tens, I have 0 hundreds, and I have 1 thousands. So let's write this out fully so we can see what this number actually looks like. So under the thousands, I have the number 1,000, 1000. I have 1,000. Let's add to that how many hundreds we have. Well, we don't have any, so that's a 0. Let's add to that how many tens we have. We have 7 tens, so the value of that is 70. Then we have 1,000 plus 0 plus 70 plus 0 ones. So that gives us a value of 1,070, 1070. Now let's look at that in binary. Okay, so this time from right to left, we have ones, we have twos, we have fours, and we have eights. So underneath in the table, under the eights, we have a 1, so we have 1 8. Under the fours, we have 0. Under the twos, we have 1. And under the ones, we have a 0. So we actually look at that and we convert that into base 10. We have, for eights, we have 1, so we have 8 plus 0 plus 2 plus 0 ones equals 10. So in base 2, when we see the number 1010, in our decimal system that we use every day, that has the same value as 10. So if we were to put pieces on the table and put them all together, it would be 10. We have 1 8 and 1 2. So we get a 10. All right, so what does the activity actually look like? So on the screen right now, I have 5 blue squares, same size, lined up in a row. And these are our binary cards. So I'm going to add the numbers of place value underneath of it. So the card on the right has a place value of 1. The next one has a place value of 2. The third one over is a place value of 4. The fourth one over is a place value of 8. The fifth one is a place value of 16. So these, imagine the students are standing up there, the cards facing them, class is out there, or facing down so they can't see it, and then they're asked to flip them over. And if your card has a dot on it, then that means that there is a 1 in that column. So we have one of those values. So in this instance, we have a dot on the 16th place. We have a dot on the 8th place, and we have a dot on the 2. So the 4 and the 1 are zeros because those are not turned on, just the 16, the 8, and the 2. So what does that look like in our base 10? So we would have that 16, so we have 16 plus 1 8 plus 1 2 equals 26. So if we look at this in binary, it'd be a 1 1 0 1 0, which is the same value as 26 in base 10. Let's do it a little bit of an extension. So students will be able to convert the letters of the alphabet into binary numbers, and binary numbers into letters to spell our words. So we have a table in the curriculum where each letter of the alphabet is given the value. So we know there are 1 through 26 in the base 10. So A is 1 0 0 0 0 0 1. B is 1 0 0 0 0 1 0, and so on all the way down. So say you want to turn your initials into a binary number. So like R is 1 0 1 0 0 1 0, 18th letter of the alphabet, and L is 1 0 0 1 1 0 0, which is 12. So then you can go back and forth, and it really helps solidify that idea of binary. But I would say go back and do the cards multiple times in multiple different ways to kind of understand those values of binary versus decimal bases. So that's our lesson on binary numbers. Thanks for coming.